All right, guys, so I'm going to go through this one a tiny bit more quickly since I did the other one pretty slowly. Okay, silver phosphate. This is ionic. Silver is my exception, so I don't need to put the Roman numeral since I know it's charged, so it's just silver phosphate. N2O, this is going to be molecular because nitrogen is a non-metal. So this is dinitrogen monoxide, not monooxide, that's awkward, just monoxide. Okay, copper chloride. Copper is a transition metal. I'm not sure if it's charged, so I have to figure that out right now. Chloride is -1. There are two of them, so that's -2 total. Therefore, copper must have a +2 charge. So this is going to be copper, Roman numeral 2, chloride. Barium sulfate. Barium, this is going to be ionic, okay, because barium's a metal. Barium, I know the charge of it. It's +2, so therefore I can just write barium sulfite. Okay, SO3 is sulfite. And guys, that's just on the chart I gave you. NH4 is ammonium. PO4 is phosphate. So just write ammonium phosphate. If you're given two polyatomic ions, just write it out. No need for your Roman numerals. This is an ionic compound between ammonium and phosphate. SO3, this is a nonmetal, therefore it's molecular, and I need my prefixes. So sulfur trioxide. Al2, this thing, right? Aluminum is a metal. I know it's charged. It's +3, so no need for Roman numerals. Aluminum dichromate. Dichromate is my polyatomic ion. All right, for lead, it's a metal, so ionic, but I don't know its charge because it's a group 4 metal. Here's the funky thing. SO4 has a -2 charge. There are two of them, so that contributes a total of -4. So lead has to have a +4 charge. This was also in the other review. So make sure, guys, you don't just take that 2, uncross your charges, and say, oh yeah, lead has a +2 charge. No, it doesn't. It has a +4 charge. So be careful. Don't let me trick you. So it's lead 4 and then sulfate. Okay. Ca3p2, calcium, this is a metal. I know it's charged. It's not a transition metal or group 4. It's a +2 charge always, so it's just calcium phosphide. NaOH, I know the charge is sodium always, so it's sodium. My polyatomic ion is hydroxide. Zinc. Zinc is one of my exceptions. It's a transition metal, but I know its charge is always 2. So this is just going to be zinc. My polyatomic ion is perchlorate. P is a nonmetal, therefore this is going to be molecular. So it's phosphorus. Remember, I can't write monophosphorus, phosphorus, and then pentabromide. Okay. Let's go down. Silicon tetroxide, silicon Si, 1 silicon, 4 oxygens. Okay. Aluminum hydroxide, aluminum has a +3 charge. Hydroxide is a polyatomic ion with a -1 charge. So I cross my charges. It's AlOH3. Make sure to have your parentheses or else you have 3 hydrogens, 1 oxygen, and that's not correct. We want 3 hydroxides together. Sulfur tetrachloride, this is molecular, so I just follow the naming, the prefixes, so it's just 1 sulfur and 4 chlorides. Ammonium phosphate, okay. NH4 has a +1 charge, PO4 has a -3 charge, so I cross my charges. The 3 is the subscript for NH4, so NH4 with a subscript 3. I need parentheses around NH4, so 3 can apply to the whole thing. And then a 1 for PO4, so I just write PO4 because I don't need that 1. Na with a +1 charge, P with a 3- charge, because sodium is a metal. Okay, so cross my charges, it becomes Na3P. Chromium 2 chlorite, this tells me my charge of chromium is +2. This is going to be an ionic compound, so I cross my charges, Cr2+. Chlorite is just ClO2 with a -1 charge. That's from your table. Cross my charges. Remember, the 2 wants to apply to the whole ClO2, so you need parentheses. Okay. Lead, that's a metal, so this is going to be an ionic compound, so I need to cross my charges. Lead has a 2 charge in this. Okay. And then nitrate, which has a -1. So I cross my charges, and it just becomes Pb, in parentheses, NO3, 2. Okay. Barium chlorate. Barium has a +2 charge. Chlorate has a -1 charge. When I cross my charges, again, chlorate goes in parentheses with a 2. Okay. Nickel 2 cyanide. Nickel has a +2 charge. Cyanide has a -1 charge. Cross your charges again. I hope this is getting super repetitive, guys. Nickel, in parentheses, Cn, in parentheses, 2. Iodine trichloride. Iodine's a nonmetal, therefore it's molecular, so it's ICl3. Tri is 3. Okay. And I will give you your prefixes on the test, guys. Xenon hexafluoride, 1 xenon, 6 fluorides. That's what I wrote. Carbon monoxide, 1 carbon, 1 oxygen, CO. And you're done. It's really that easy. So keep your head straight. Always think, okay, is it an ionic compound? is it a molecular compound? If it's ionic, okay, think it's a transition metal except for Ag or zinc, or a group 4 metal. If it is, then you're not sure of the charge and you need your Roman numerals. If it's not, then you know the charge and you don't need your Roman numerals, like here. If it's a molecular compound, you use your prefixes, which you'll be given on the test. Don't use prefixes when you have an ionic compound. Please, please, please. Okay? When we're writing the formula, if it is an ionic compound, cross your charges always. Always, always. If you have a polyatomic ion, put it in parentheses if you have more than one. If it's a molecular compound, just use the prefixes to tell you how many there are, and please don't simplify, right? If it's N2O2, leave it as N2O2. For ionic compounds, simplify. Molecular, don't. And that's it, guys.